Assalamualaikum, this is Anna Fatma. Welcome to my YouTube channel. In this video, we will discuss about Leibniz series. So what is Leibniz series? We use Leibniz series to find the nth derivative of two functions when they are multiplied with each other. We all are familiar with this formula. I am sure you all are familiar with this formula. U dot v is equals to u derivative of v plus v derivative of u. But we use that formula when we know that how many times we are going to derivate our functions. In Leibniz series or in this series, we don't know how many times we are going to derivate our functions. So we will use the Leibniz series. Let's start it with the example. Let's consider we have to find the nth derivative of this function. So here we can apply directly u dot v, but we are questions to find the nth series. So what we will do, we will take u ex exponential of x and v 2x plus 3 cube. How do we know that we have to take 2x plus 3 whole cube? V and u should be ex, because we take v, the function which will be reduced itself. So we use v is equals to 2x plus 3 whole cube here. What we will do, we will simply differentiate this. How? We know that the power will be used first. So we will write 3 into 2x plus 3 whole square, and then we will take the derivative of the function which is this. So the derivative of 2x will become 2 and 3 is a constant, so its derivative will be 0. So when its derivative will be 0, we will multiply this 2 with 3, so we will get 6 into 2x plus 3 whole square, the thing that is written. Similar goes for v2. We will take the derivative of this part now and we will differentiate it, like we will multiply 6 to the 12 first, we will get 12, and then when we take the derivative of this function we will get 2, so 12 to the 24. So here we have written 24 and the function is written first time for the first derivative. What we do, we take the derivative of the power, multiply the power with the coefficient of the function as we did, so we get 12, and then we write the function itself. So the function is written which is 2x plus 3, and then we take the derivative of the function. So we know the derivative of the function will be 2. So 12 into 2 will be 24. Similar goes for this case. We will multiply, we will take its derivative. 24 is a coefficient. The derivative of 2x plus 3 will be 2. So 24 into 2 will be 48. So what we observe from this, we observe that we will have to differentiate 3 times. So we will get the final constant value from this part. That's why we have used v to this function, because we knew that when we do this we will reduce our function to the constant value. So this is original function which is u is equals to ex. We take its first derivative and has gotten the original function which is ex, because we know that the derivative of ex will be always ex. So here goes the same for the second derivative of the function. We got the same ex. That's why for nth function we didn't change it. For n minus 1 we didn't change it. And for n minus 2 we didn't change the function. So now we will apply the Leibniz series over our function which is u, v, n. So u and v, we had u n which is ex, so we have applied this here. Our v was the original function which is this, and n u n minus 1 v1 So here n is this, un minus 1 is ex, and v1 is 6 into 2x plus 3 whole square. Then for n into n minus 1 upon 2 factorial, the same is written here. The factorial of 2 is 2. Un minus 2 was ex and v2 was 24 into 2x plus 3. Then for n into n minus 1 into n minus 2 upon 3 factorial, we wrote it here. And then for un minus 3 it was ex and v3 was 48. And then what we did, we simply cut the values. So we cut the 2 with 24 and it is 12, and then for 6 and 48 it is 8, so we just wrote it simply. So this is the answer for the nth derivative of your question, which was this. That's it, the end. I hope you liked the video.